Hey guys, thanks for stopping by. This is Joe, and I wanted to get this video up so that I could start helping people out, get a better idea on how to deal with electrical systems as a tutor. In circuits, I have noticed that there's a couple things that tend to drive people confusing, drive them batty, get them frustrated. And what I wanted to do was put this video together in a way that would be able to help people out and also let them know that if they are trying to get a different perspective, probably a better understanding on how these systems work, and they are seriously motivated and interested in working with somebody, um, and I am able to put it in terms that you understand, where you understand what's going on with regards to electrical components and circuits, then I would hope that I would be the one that gets to work with you. Now, I do understand that in some cases I may not be the best choice. That's no problem. And I do understand that for whatever reason, if you have somebody that puts it in better terms for you, that work for you, then lock and load, keep moving, don't look back. But my objective is to try and provide a different perspective and try and help the students that are either the traditional high school student rolling out into college or the university taking circuits, or the person that's been in the trades for a while and they want to start moving and becoming more advanced in their work, or the person rolling out of the military and saying, hey, I like electrical systems, I'd like to get my degree in it, or the project manager that's sitting there saying, I don't understand these electrical systems, but for gosh darn it, I need to figure out how to get these things, why I need to understand why these things are so complex. But more importantly, I need to know why they are the way they are and why these other trades may have a time longer than normal in doing this type work. So for that person who's not in the electrical trades, I'm actually able to work with you in that case where you would like a better understanding of what's going on. Am I the be all end all for all things electrical tutoring? No. I have no interest in that. That's above my pay grade, and no. I keep the happy feet on the floor, and that's how we do that. So my objective is to make life a little bit easier so that I can provide insight based on my 3.5 decades of working in the profession so that people can get a better understanding of how these systems work and operate. But I also think the best way to do that is start at a baseline. And one of the things is this video specifically is for introductory purposes, for informational purposes, and I'm trying to take a very huge topic, a huge domain, all the way from semiconductors all the way up to transmission systems, and sit there and say, let me work with the people who have questions about the systems that I know inside and out, in addition to having manufacturer certifications on, in addition to having licensing on, and in addition to my current degrees. And if I'm able to help them out to move forward, then at the end of this video, you'll see the link that you can use to find me, and I look forward to working with you, be it one-on-one, one or two different times, or however you need to move forward. I'm pretty much flexible and able to work with people. The thing is that if you're looking for the person that just gives you the answer to the question, not your guy, please move somewhere else. I don't think I'll be able to help. If you're looking for the guy to do your homework, not really interested in that either, because I'm here to work with people. And it's like something I enjoy doing. So my experience in the field over the decades, from the military to the manufacturer domain to freelancing and putting fires out and making stuff and more equipment usable and understood, the best way for me to approach this and help others is say, hey, let's start with circuits. Now, you're going to find these two breadboards are the fundamentals which result into those little things known as variable frequency drives or motor control systems. You're going to find it in high voltage control systems like your power electronics and your protective relay systems. You're going to find it in switchgear. But the thing is that you want to do it right so you don't have these problems. And sometimes things fail. And when they do, hopefully the manufacturer of the apparatus that was installed actually did their destructive testing to make sure, hey, if this goes south, how do we contain the catastrophic event without getting anyone injured? And that's a domain that you're never going to get access to because you're the consumer. This is product development, and we don't need to discuss that with anybody but other engineers who do product development. These two guys are for your students who seriously want to learn all things electrical. This is called Ohm's Law. And Ohm's Law is the one universal guy that will help in many scenarios. It will not help in every scenario. It will work beautifully in DC systems. It may work with AC depending on the configuration and the system that you're working with. But for the person starting out the semester, or for the person going back to school, or for the person taking the course, or for the person that's trying to study electrical systems, memorize this. Stop the video. Write these formulas down, the guy on the left, the guy on the right, because what's going to happen is those little formulas there on the right side are going to be your best friend, and they will tell you when it comes to amps, volts, power, and ohms, what formula you need to get the value that you're looking for to solve the equation you're faced with. This is universal. If you're in the trades, if you're in the military, if you're in the civilian sector, if you're working for industry, these are the happiest guys on earth. Do they solve every one? No. Do they solve most of the things out there? Yes. But putting this on index cards, making the flashcards for these formulas, once you get this to memory, and once you start your first quiz, once you start your first exam, once you start your final exam, and you have this written down because, hey, it's exam time, and sometime that exam knows you better than you know it, this is your lifeline. And if you're able to put this to paper outside of a cheat sheet that you were provided when you started the exam, this guy will save your bacon. Just saying. Really good suggestion for you. Okay, let's get to the SI domain. In the electrical on the bottom, we've got our amps, volts, ohms, farad, Henry, watts, and hertz. You also have your charge on the Coulomb and your other breakdowns. These are some really good guys that you want to have on flashcards. Trust me, the better you know these, the better you're going to do. Though it's chemistry, components, and nomenclature, we use it in electrical, but getting it under the belt and kind of memorized, the happier you're going to be. This is really important, and here's why. For the folks that wander down the street after taking circuits, and you decide to go into solid state devices, or you get into photovoltaics, or you go into power systems, you want to pay attention to, well, the positive 3 and the negative 3, and you want to make sure that you got these guys sorted out. Here's why. In the solid state domain and in the photovoltaics, you're not going to be using milli on a regular basis, but you'll be hitting that micro and that nano, and you may even hit pico. Just saying, because that guy will drive you nuts if you have not remembered where it was. And for the folks on the power system side, kilo and mega and giga. Yes, because we like power and that's what we do. So kind of important, get these on flashcards, get these under the belt, because the sooner you get this done, the happier you're going to be. Now, here's the problem. You're taking coursework at a facility or institution or a training center that is going to be using a textbook. Not all textbooks are the same. So my videos are not going to reference one textbook. They're not going to reference a specific book. So my focus on is to hit certain topics where people have problems. But I wanted you to take a look at not the first row from the top, the second row from the top. The third row is inductor to the left. Next guy in the center is 10-volt DC battery. That is a battery symbol for 10 volts. Notice the positive and negative. Positive on the top, negative on the bottom. Next guy to the right, third row from the top, is 12 volts AC. That sine wave means it's a sinusoidal voltage waveform. So that's kind of important because AC and DC, they operate differently initially. We'll save the rest of that for another time. Very bottom, you have this thing known as a dependent voltage source on the left. Very bottom, dependent current source in the center. Know the symbol, know the book value, because sometimes some books are not going to play nice. Really important. And here's the example. That guy on the right that says 15 ohms, 20 ohms, and 25 ohms. Can't really screw that up because, well, that's the symbol, that's the value, and that's the nomenclature for that part of the series circuit. The guy on the left, he's different. Yes, it's positive and negative. What's that mean? That means it's implied DC. It says 180 V, which means I think it's going to be a DC circuit. If you are handed a quiz, exam, final exam, and somebody does not have a symbol that is clear and concise, stop what you're doing, hands up. Excuse me, Proctor. Professor, ma'am, can you help me with this? Professor, sir, can you help me with this? I have a question. Is this an AC source or is this a DC source? Whatever textbook you're assigned is whatever textbook you're assigned. Some professors may not even do it in a textbook because they've been doing it that long and they're that good. They actually exist and they're great professors. Other professors will use a textbook that doesn't use traditional symbols. I would not call that 180V a traditional symbol. Find the reference book that has the formulas that works for you because of that issue. This guy's a little bit different. We got all the resistors there. We see it's 30 milliamp. It's an arrow going up. That's a current supply. Pretty clear, pretty concise. So they're the kind of important things that I want to draw out. And I think it doesn't matter which direction you're going. But when it comes down to dealing with electrical systems, I think for the most part, it's, can I get information that is consistent? Can I get information that's clear and concise? Can I get information that can explain why it does what it does? And I would say that in a situation when you're trying to figure out how it all goes about, feel free to contact me there at wyzant.com tutors field. And I'm Joe. I look forward to working with you. But I think on the other side of the point too is that when you're dealing with these topics, you need to find the person that puts it in terms that you understand. You need to find the person that explains it in a way that works for you. And I would hope if you have that person, then keep rocking it. Have a great time. If you need some additional help, you know where to find me. And I'll post a few more videos in the future, but in the long run, I look forward to working with some new people, and hopefully I can be of help. Till then, have a great day.